Hi. Welcome to the parallel universe. Derivation of the resultant vector of two vectors using parallelogram law of vectors. Imagine two concurrent vectors, vector A and vector B are represented by the two adjacent sides of a parallelogram OP and OQ respectively. In this diagram OQSP representing the parallelogram where OS indicating the resultant vector of vector A and vector B, which is denoted by vector R. To derive the formula for resultant vector, extend OP to N and draw a normal from the point S on the extended OP at the point N. Now from right-angled triangle OSN, applying Pythagoras' theorem we can say OS square is equal to ON square plus SN square. Now ON can be written as OP plus PN. Therefore, ON square will be OP square plus PN square plus 2OP, PN. And thus, OS square, which is representing the magnitude of the resultant vector, is equal to OP square plus PN square plus 2OP, PN plus SN square. Substituting OP to A, PN to B cosine theta and SN to B sine theta, and simplifying we will get the final expression for magnitude of R as shown in the figure. To calculate the direction of the resultant vector, consider the right-angled triangle OSN. Tan beta is equal to Sn by On. Now after splitting On to OP plus Pn and substituting OP to A, Pn to B cosine theta and Sn to B sine theta. And simplifying, we will get the angle beta, which is equal to tan inverse B sine theta by A plus B cosine theta. Hope you find this video helpful. Please like and share this video. And subscribe to my channel for more such contents. Take care, bye.